Notification on that. There we go. Recording has started. Okay. So, Aaron Eberhard here, Vector Manufacturing, here with Jason from Area 51, Fabrication and Manufacturing. Jason, tell us a little bit about yourself.
Hey, buddy, how are you? Let's see here. I am a 25 years in business now. I am self-taught. Didn't really have too many mentors in this space. I started in just general fabrication, and general fabrication became precision sheet metal, and precision sheet metal customers demanded machining processes, and machining processes then turned into machining work, and um, I am all self-taught. I do a lot of 3+2 stuff, and I'm decently comfortable there. But we've expanded into um, 5-axis and 3+2 machining. I bought a UMC 750 last year just because I wanted to kind of jump in head first, and that's just the way that I learn, is just get it and try, and been largely successful muddling through this stuff. However, I've reached I think my breaking point with this part, and
Yep.
this is a part that's part of a weldment. It's 6061 T6.
Okay.
Yeah, I'm in over my head. My fundamentals are very lacking, and I'm sure I do everything wrong. So yeah, I'm a student to this.
All right, cool. Well, thanks for the intro. Yeah, so obviously you've said you're going to be throwing this on a UMC, and I think I just have the 1250. Oh no, there. I do have a UMC 750. Hopefully you're using the postability post, because then I could hand this right off, but if not, you
Yep.
can sub it with whatever you got. Um all right, now we're making it out of 6061. What's the material size? Do you know off the top of your head?
So I don't. I had come up with a blank size of approximately 5 by 5 square, looking at it from that base,
Okay.
and I was
Yep.
looking at making the blank length like 6 inches, 7 inches. My thought was
Okay.
oriented like that, or I was actually orienting at 180 from that, but further standoff, yeah, from the vise would give me better
Sure.
access. I think it would be fairly rigid, but those were my
Okay.
thoughts.
Sounds good. Yeah, we could absolutely do that. Get yourself a little bit. You're just gonna hold it in like a fifth axis work holding or something like that.
Yeah, I have one of those Haas yeah, 5th axis
Oh,
vices.
okay, great. Yeah, so we're basically gonna be holding it more or less like this, probably on the bottom with a dovetail or something, and carve it away.
Yeah, and my only thought was that I'd have better access to that undercut
Yep.
tab feature when holding it that way, and
Yep.
have remaining stock facing the
Yeah.
bottom. But like I said,
Totally agreed. No, 100% agreed with that. So let's just drag that down and give ourselves, I don't know, like 20 thou on the top or something like that.
yeah, that's actually generally what I do.
Yep. So, whoops. Did I get that? No. Oh, right, I'm upside down. Negative 20 thou. Okay, cool. Um, so yeah, let's just slap a coordinate system on here then, and we'll assume that this is what we're going to be machining. And midpoint and midpoint. Okay, so we'll call this G54. All right, so that's where we're going to be working today. Let's give ourselves a level. Stock 5 by 5 by 6. Let's move selected entities. Okay, cool. So now we have a rough idea of what we're going to be doing. Now, you were saying a little bit when we were chatting before that you want to talk about different strategies for roughing, but the big problem here is probably finishing, right?
Correct. Yes, I am stuck in old toolpath. I don't do very much dynamic. I cut a lot of air.
Yeah.
This instance, I don't even know if there is a toolpath that I can apply that would rough the majority of that. But yes, finishing would definitely be my biggest goal. And just general parts approach. I don't know if I have a sound strategy for how I would access most of this part.
Okay. Yeah, I mean, and just for anybody watching, I had probably less than 5 minutes to look at the part as well, so I'm just kind of winging it as always. So we'll walk through it, and if we get halfway through and realize that there's a better way, well, should have thought about that ahead of time. That is actually one of the for a part like this, it's not nearly as big of a deal, but for a lot of multi-axis parts, I really do spend a lot of time before I even ever put a toolpath on, just figuring out, how I'm going to hold it, what I'm going to cut it out of, all of that fun stuff. Obviously, here we'll be able to, you know, we'll just see where we end up, but because it's pretty straightforward, I think. Now, on the roughing side, so let's just start there. I mean, it's going to be hard to beat in Opti just so, I'm talking, and by that I mean an Opti rough, using a dynamic Opti rough
Okay.
to rough that material away. Because we're not talking super long or anything. This whole part is only what, 3 inches tall, is it?
Yeah, just
So
I think.
yeah. So 3.8. So I mean, there's in bigger parts you can get a lot more elaborate with doing like multi-axis roughing where the parts kind of spinning as you rough material away and all that. But when you're talking 4 inches or less really of tool stick out, I mean, that is well within the range of a normal 3-axis roughing, as you know.
Yeah.
I would just run it. Probably we're going to start out with a 3-axis roughing op. So let's toss an Opti on there and chat through it. Um, so I know you haven't had a ton of formal training, but you know how these panels work for for the Opti toolpaths or the high speed where you could control what you're machining and what you're avoiding and everything?
Yeah, for the most part,
Okay.
I play with this with some degree of success as far as understanding the avoidance regions. And again, we talked earlier about like the algorithms and how things work.
Yep.
I've kind of I understand conceptually the avoidance things sometimes net me results that I don't anticipate, especially like
Right.
with holes. I have to fill a lot of holes and things like that. Um,
Sure.
yeah, so but I
Yeah,
do
it's
understand the
yep.
fundamentals.
Okay. So yeah, the thing that trips people up on this, the number one biggest thing is anything that you select has to logically be included in the algorithm somehow, right? So if you select avoidance regions, for example,
Hmm.
everybody's thinking, oh, okay, well, it's going to act as a trimming boundary that the toolpath won't even go over that area.
Yep.
Logically, that doesn't even make sense, but as a human, that's the first thing you think. Like, oh, if I tell it to avoid this geometry by 50 thou or 100 thou, it's just not even going to cut in that area.
Right.
No, you're telling it exists, and you're telling it that you need to be aware of this, but I just need you to stay 100 thou away.
Understood.
Yeah, so if you need an area, and we don't in this particular case, but if you wanted to avoid cutting inside of an area, your avoidance is really just telling it stay this far away from this thing and don't go out of your way to cut it. But if it's part of, if it's wrapped up inside of this area that you are machining, basically just stay 100 thou away from that, even though you're only staying 20 thou, or if you're finishing everything else. The
And-
toolpath control is where that really is controlled. So
Okay.
if you had a complete area that you wanted it to avoid cutting in 100%, you would have to do that with a boundary chain.
I gotcha.
So basically, anything that it's aware of here, it's going to use to build its model in the background of what it's doing. And I mean, it's pretty straightforward. Like what I found with all cam systems, obviously, I worked at Mastercam, so I do know how the sausage is made, but it's all the same across the industry. If you, as a human, think through how would I make this algorithm? What would I do? You'd be like, oh, well, I would take the machining geometry and I would make a little model that's kind of puffed up around it. And that's what I would bring my tool into contact with, right? That's exactly what's happening. Like you take this thing and you say, oh, I want to stay 50 thou away from everything. It's taking this and puffing it up. And you can kind of see that. I'm going to cancel out for just a second. No, don't save that. If you make a stock model on these things, let's turn off the stock plane and we're just going to select that. And we're going to say, oh, additional offset of 50 thou. Why did that create? Why did that do that? Let's see here. Hang on. Let me save as. Okay. Oh, this is no. By the way, do you use Mastercam 2024?
I'm on 24. Yes, sir.
Okay, yeah. There's a bit of a bug that can sometimes happen using stock models and sometimes Optirough, where if you transform dynamic things, it'll sometimes include that in the model, and then as soon as you save it, it goes dirty. And then when you regen, it's fine. I think that's all fixed up now in 2025. So I haven't ran across it in a while. I thought it was fixed up in 2024, the latest update, but I guess not. But either way, yeah, so you see how, this is kind of like a puffed up model.
Yep.
That's exactly what the toolpath's going to be driving against. That's
I,
that's how that's how they work, right? So then if you came over here and you were like, I'm just going to draw a cube here or something, but say you had a shape here, um, move that back to here, turn that off. And I'm just going to kind of drop this into this area, right?
mhm.
So now if you told it, oh, I want to avoid that as well, it would be as if you came over and said, I want to avoid this cube by 200 thou, or whatever you're trying to stay away from it. Why is that not generating? Clear the model. There we go. Additional offset. Do 125. See if that's happier. Nope, I don't know why that's not generating. Stock models making a fool out of me today, I guess. But basically, it's just going to include that, and you're just going to get a model that is puffed up more around that cube.
Sure.
Oh,
Now
same
let me
thing.
ask you this: containment boundary. To understand
Mhm.
containment boundary, if I had, let's say, a pocket that had a ton of bosses and stuff like that within it, and I just wanted to Optirough just a portion of that pocket, could I
Mhm.
simply create a chain or a boundary and select it as a containment boundary, and it would only Optirough within that
Yeah,
given
yeah,
area? Is
that's
that how
that's
it's used?
absolutely, the way it works. Like if and I'm just going to go back to 2D dynamic for a second because I think it's kind of easier to understand in 2D dynamic, but it works the same way. If we come in here and we create a toolpath in a 2D dynamic square like that.
Mhm.
So I'm just going to hit OK and get what I get. All right, so there's my toolpath. So if we go in here and we say, let's make these, I don't know, black or something you can see. All right, so we come into our chains here and we say, oh, I want to contain it to this area. Now, if we look at the chains, what it did was it said, I can machine this entire white square, but I'm going to keep it inside of the black square. And that's exactly what
Okay.
happens. And think about, again, just I like to go back to all of these were built by humans, right?
Right.
So follow the logical workflow. Like if you were designing a cam system, the very first thing you'd probably develop is a contour style toolpath, something that traces around, traces a shape. Now you would go, oh, how can I apply that in different directions? So all the way through with every single toolpath that you go, and in this case, we're using Optirough to rough this out. So that starts as a 2D dynamic. Well, how would Optirough, a 3D toolpath, work? Well, what you do is you take your 2D dynamic and you'd slice your model and make 2D dynamic mill slices, and then you'd create models in the background to do like step ups and all the other magic that happens automatically. But you could really boil almost all toolpaths down to the kind of 2D component of it. So if
Understood.
you can understand how it works in a dynamic mill toolpath, the same exact thing's happening in an Opti toolpath.
Okay.
And you sort of like telling it that this is an avoidance region. Literally, it's the same thing. If you were to do an Opti, if this were a 3D shape, it would recognize at this slice, this is a boss.
Yep.
and I need to avoid cutting that boss.
So it's almost like doing dynamic in depth cuts, but every time it gets to another depth, it's looking at new perimeter basically as you slice through the
Yeah,
model. Yeah.
yeah, exactly. Like if you came through here, and I'm just going to do this really crudely because I mean, we can, create relative. Let's give me the front plane to work on. Okay. Because I mean, if you came through and did something like, I want to step down every whatever half inch or whatever lines I happen to be drawing, and then came up here and did a project these 3 lines onto that, and we're going to say that 1, 2, 3. Basically this is what's happening in the background.
Understood.
Yeah. And so you have 3 different optis that are using these things. And then if you had to do like the step ups inside of the opti, well, what it knows then is that the previous depth did this, and we're going up to this, and it's again, there is intelligence there, of course, but when you boil it away, this is what's happening. Is it's basically a 2D toolpath that's been stepped up, and the same thing that it sounds really wild to say. We're not going to get super deep into it today, but if you got into some of these surfacing toolpaths, it's the same sort of thing that's happening in the background. They're
Gotcha.
figuring out, okay, if this were a 2D pattern, then we could wrap it up, or we extrapolate how it's not a 2D pattern by looking at the topology of the surface.
Understood.
Yeah. So yeah, if you come into Opti though and you were like, oh, I wanted to avoid cutting in this area, right here, maybe the way to do that, instead of trying to do a bunch of avoidance and everything like that, let me get rid of all my wireframe here. Um, the better way to do that would be to say something like, I would like to cut
The max
this
and pen.
area.
I gotcha.
And that's generally easier because again, if you give it part of it as, like an avoidance region, you got to still make sure you do that because that's what keeps it from staying, 100 thou away from this wall or whatever, as opposed to the 30 thou that you're,
Yep.
you know, but yeah, so let's dive in here. Let's do a Opti, and we're going to come in. All right, and I'm just going to leave 50 thou away. That's fine. In this case, my boundary chain, I could manually choose my stock. I'm saying this is my boundary. Like this is where my volume comes from to remove. And I want to come from the outside of this, right? Now, to rough this out, this is aluminum. I'm There's a bunch of tool brands. I'm not married to any single tool brand at all. I work with so many people in the industry. Um, the big thing that I'd be looking for to do this is a extended neck, and I found Helical seems to have a really great selection of those in stock that does an excellent job. So I'd say let's pretend we're going to be using like a Helical, and maybe we're going to use a half inch, 6 inch overall length. Cutting lengths probably end up being about 1 inch, 30 thou radius, and shoulder length give us like, I don't know, 4 inches. And then this would probably end up being like a 480 or something like that. So we get that nice reduced neck. We're not putting a lot of tool load on. And the other thing that I like about them is they have an excellent calculator for feeds and speeds. But if you don't, I always like to pitch, and I'm not affiliated directly. This is the HSM advisor from Eldar, and he does an amazing job if you haven't played with this. Basically you can come in here and be like, oh, I have a half-inch end mill and it has 3 flutes and it's sticking out of the tool holder 4 inches and the flute length's 1 inch. Give me my recommended dynamic settings. It'll tell you the width of cut, it'll tell you the depth of cut, and it'll give you the feeds and speeds that it recommends. Now, this is aluminum, so obviously it's all the RPM all the time. You're on a UMC 750, so you probably have what, a 12,000 RPM spindle?
15,000.
15? Oh, okay, cool.
Yep.
So, that means that we're going at like 80% of the recommended, or the theoretical 100% for this, because again,
Sure.
it's aluminum. And you probably don't even want to run it there, so maybe we'll go 14.5, just that way we don't beat it up unnecessarily.
Oh, I got
Um,
to get through one. That's always my policy. So.
nice. Um, but yeah, so it's saying like 225 inches a minute, 14.5, and then that's recommending a little less than 9% step over at 875 depth of cut. And of course, always if you use them, the helical and Harvey tool calculator is awesome as well. So yeah, I'm just gonna come in here. We're gonna do 3 flute, and that's 225 at 14,500. And I'm not gonna fill in everything else. You could do that. You're responsible to make it look good. Okay. Um, so this one, just by default, my machine is set to 12,000 RPM limit. So,
Yep.
which is the default behavior. So I'm going to slow that down a little bit, which would be 154 inches a minute. Okay. So yeah, I mean, everything here, you probably have a generally good idea of how to use this stuff. Um, One thing that I like to point out to people is, in a case like this, I would not be doing this bore until the very end, because
Yep. I
keep
agree. Keep it
yeah, keep
rigid.
everything super rigid. Um, so a lot of people would start out by trying to cap that, either creating a flat piece of geometry or whatever, a solid plug, or editing the solid itself. But in a lot of cases in dynamic, you can just come over here and say skip pockets, and I'm going to say smaller than this diameter, or you could even just tell it skip all. Um, and there you go. It should skip it right for us, and then we don't have to do anything special.
Oh, no way.
Yeah, that's under the toolpath control.
Oh,
Um, yeah. So then, our cut percentage, like I said, I think it was 8.9% it recommended. And then we're going to do a 875 step down, and we'll toss some step ups in there, maybe quarter-inch step ups. So cool. And then, your steep shallow, you probably already figured this one out, but basically this controls where the maximum depth of it is going to be. And so basically you could say, oh, I want to come down here and I want to go a little bit past wherever that is. We're just going to go, I don't know, quarter-inch past that. Top of stock. We don't need to define it. It's going to know where it's at in the model, and we're not really going above it, right?
yeah.
All your linking stuff, this is where you just set up. Um, there's not too much magic here other than make sure that you remember to put your back feed rate at whatever the max feed is. That way it, zips around quick.
Yeah, and don't assume I did not know what steep shallow was
Oh,
used
really?
for this instance. So that is
Oh, okay.
helpful. Yep.
Yeah,
I
cool.
now.
Yeah, no, no. So yeah, sorry about that. But yeah, steep shallow is literally just, if you're looking at this in the top plane, which is what
Yep.
we're looking at it in, what Z do you start machining at and what Z do you end machining at?
Yes, sir.
Yep. Now, oh, one thing that'll really throw you off, especially when you're doing finishing operations, is you came down and you said, oh, I want to go down to the bottom of this part. However, you also told it back on the model geometry page that you want to leave 50 thou.
Oh yeah.
So that creates, there's a lot of people who really struggle with that. And we probably won't get into it on a part like this one, but you'll see that on like bigger or shallower parts where you're trying to do like depth steps. You'll end up with this extra, like, whatever you said here. Oh, I want to do a 50 thou stock to leave, and it'll come around, it'll machine everything, and then it'll drop down and do another pass 50 thou below it,
Yep.
because it took that model and it puffed it up. And then you said, oh, I need to machine between this Z and this Z. And the part is now kind of above that. So it started lower than you expected, just looking at it at first. And sometimes the math gets a little weird. So the number one thing that trips people up here is these little check boxes where you tell it, I want to, in this number, when I tell you this number, I want you to include stock. And I also want you to adjust that for my stock to leave.
I got you. Yep. Yep.
Yeah.
Yep. I understand.
Yeah, and that's a little more, in this case, again, we're not going to see it. And I don't need to do that because I just told it, oh, go, an extra 1/4 inch below the bottom of this. But you will absolutely, that is the number one thing that I see people fighting with and having a bunch of extra cuts because they'll select something that has like a floor and then it tries to cut the outside of it
Yep.
because it's allowed to. And so this keeps you from having to do that math. Like, no, 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 my maximum depth is actually this plus 0.05 plus my radius plus, crap like that.
Yep.
And so do you know about microlifts and how to control those and what they're doing?
I'm familiar with what they are.
Okay.
I definitely don't pretend to know everything. So please
Okay.
feel.
Yeah, so basically, let's see, what is my back? What's my max back feed rate? 100? Nope. This machine set up probably to 500. That's the default. Okay. So basically, the idea is, of course, when we cut, we're going to be spiraling into material,
Yep.
but we're only going to be climb cutting. So it has to pick up the tool kind of rapid, not a G0, but as quick as possible, zip across the part to go back and climb cut again,
Yep.
kind of getting that peel mill idea. And so the micro lift here is just how much are you going to pick up and how fast are you allowed to move across to zip from one side to the other.
Yep.
Um, so the micro lift distance on a good newish machine, honestly, the only important thing here is that you're not dragging the tool across the floor at 1,000 inches a minute.
Yep.
So basically, this is one of those you kind of need to know your machine a little bit, but if you go out there and you MDI and you say move up in the Z 2 thou, are you going to see 2 thou movement on an indicator on your machine? Yeah, probably within reason, right?
Yep.
So you don't need to pick it up very much at all. But if you're working on a clapped out old Fidal and it has 10 thou of Z axis backlash, and you go in there and you type in Z plus 8, sure, the ball screw's moving, but you're not actually seeing any movement at the tool.
Yep.
You need to go bigger than that. That's what that number's for. You're just
Understood.
literally like, I just need to pick up the tool a smidge. Generally, 5 thou I find is like a good compromise, but if I'm on a really well-known machine, you might take that thing down to 2 or 3. You're just trying to lift up a little bit so you don't drag the nose of the tool across the part at whatever this number should be. And you might need to get your machine configured, but this number should be whatever the fastest your machine can cut.
Gotcha.
Like straight up.
And it's never obviously going to encounter any type of cutting geometry.
Correct.
Transition.
Yeah.
So there's no chance it's feeding through anything. You're in air.
Yeah, exactly. So yeah, exactly. So this, if your machine can go 1,200 inches a minute, then this is what you want to type in. And it's always going to be in a G1. It's always going to be control. You're never going to get that weird, like, rapiding dog leg thing that you sometimes get.
Yep.
So, yeah, I mean, there's no harm generally in putting like 1,200 inches a minute here.
Okay.
Because, and the other thing is, if you're inside of a little pocket, you're never going to actually reach that either.
It'll never
right?
accept. Yeah, it's asinine. Yeah.
But that's up to the control to slow it down and keep everything in sync. And they do a good job nowadays. So yeah, absolutely. Put in whatever the max you're allowed to put in here. And you might need to modify your machine definition to allow higher. Like if this were my machine, I know that a UMC 750 can wrap it around at 1,200 inches a minute, I think, or
Okay.
1,100. I forget what the limit is, but I would make sure that I could type that in here because it's just free time.
Now, where it says, not to cut you off, where it says micro lift retract and that's set to never, would it perform none in this instance or?
No. Nope. This is so it used to be in the dark ages back in 2023 before they redesigned this lead in lead out page and we had room for a picture. So basically the idea here is that when it's in that micro lift, it will never pick up and go into a G0 rapid.
Okay.
But you might have a large part where it makes sense instead of trying to zip around close to the part at 1,200 inches a minute, you just want to pick it up and go at G0 from here to here. By default, a dynamic toolpath will never do that.
Oh,
ever.
I got. So wait, I'm reading micro lift retract and assuming that is inferring micro lift. It is a retract, but this would be retracting beyond what the micro
Correct.
lift would be. Yes,
exactly.
Okay.
Yep. And you could say, and that ties into right up here, this keep tool down within.
Yep.
So if you want to say, hey, if you're moving more than 5 inches, I want you to retract.
Yes, sir. I got it.
So, yep. And that's another thing that does trip people up here is by default, this is set to never ever do it. So you end up with this sometimes weird situation where the micro lift is like going outside of the part and tracing the back of it to get back into the cut. And you're like, I just want you to pick up and go over,
I've
just
actually encountered that before, where it'll run around the part to get to the other side without picking
right.
up and going over, and that's this.
Yeah. And you're like, why the hell? No, I don't want
Yep.
that. Well, so
Okay.
what you need to do is tell it. So what's happening there is it's trying to avoid a boundary.
Yep.
And so you could tell it, well, hey, you're allowed to retract if you're avoiding a boundary.
Gotcha.
Or you could do it when you're avoiding a boundary, or if you exceed X inches.
Yep.
Or you could do it when you're avoiding a boundary and exceeding it. And that's the only case. Like if you're avoiding a boundary, but it's going to be less than 5 inches, I don't want you to go into a G0 mode.
Makes perfect
So
sense.
yeah, so that's exactly, and then of course the last one is just whenever you exceed 5 inches of movement, rapid it instead. So, yep. In this case, it won't really affect us. Again, you ran into that where you were machining some parts that were kind of longish,
Yep.
and you had sort of a different size pocket on the left than you did on the right, and then it did that weird thing around the back of the vise, and then you're like, why the hell? How do I stop that? Stay here.
Yep.
You know,
Yeah.
that's exactly what it was doing.
Super inefficient, and I was like, "What in the world is it doing?" And I just let it. My
Yeah,
ignorance let it do it. So
right. But yeah, so this is the number that you would have done is you would have said, oh, if you're avoiding a boundary or exceeding whatever inches, 5 inches, then you could wrap it and then it'll just pick up and go over the vise and go over to the other side or whatever.
yep.
And then of course the other thing you just need to make sure that your clearance plane is set up correct for that.
Understood.
Um, so yeah, and then the last thing I always like to talk to people about is arc filter tolerance. So this is another thing that people don't really understand. I'm going to generate this toolpath real quick. I don't want to save it yet. So let's see here. So here's okay, there we go. There's a toolpath. Um, so this thing right now, if we look at the toolpath, we kind of got what we wanted. We're starting out deep, we're stepping up. Now we are machining the top face of that, which we may or may not want to do with our little 1/2 inch end mill. Doesn't really matter, whatever. So we've got this shape. Overall, the toolpath's great. However, if you look at this right now, you're going to see that the NCI size, if I post this out, it's going to be like a 10 megabyte file, which on your modern machine on your Haas is not going to be a big deal. It can handle that honestly without any problem. But if you've got one of your older machines, you got an old Fadal in the corner and you try and run this, it's going to choke. And the reason for that is all of these moves in here of this toolpath are little linear movements. And it's creating them. Each one of these little steps I'm going to put on the endpoints of the toolpath. Each one of these are just little lines. And that's frankly excessive. There's no reason for that. So that's where the filtering comes in. I'm going to create a copy of the toolpath. Just that way I can show you the difference here. So what this is doing is this is saying, okay, and again, remember how, how the toolpath works and how things work together is really important to the fundamental understanding. So as you work down through these toolpaths, top to bottom, everything sort of happens sequentially, and we're going to be talking about that a lot in the multi-axis one in a minute. But same thing happens here. So we've gone through and we've specified our model geometry. We know what to cut. We've specified any boundaries we need, our cut parameters, whatever. So we know that we're going to generate a toolpath to this point. Anything after we get to this cut parameters now, so it's going to calculate that toolpath in the background. And then it's going to go and apply all of the linking settings. And then if we put on arc filters, it'll take a look at the remaining toolpath and go, okay, now I'm going to filter that out. And it's a kind of post-processing thing. It happens sequentially top to bottom. Like I said, in 3D toolpaths, that isn't as critical to understand, but when we do multi-axis, it's absolutely critical. So yeah, basically what we're doing is we're saying, what is the tolerance of the toolpath? And what that really means, and I know this is a mess to look at the moment, so, just play along for a second. We're cutting along this outside circle, this outside edge of the circle for whatever reason. Now, we've told it on our model geometry page that I want to leave 50 thou of material, right? So this whole thing's getting puffed up 50 thou. How close do we have to hold the shape of this cylinder, even though we're puffing it out 50 thou? Well, the answer is by default 1 thou tolerance. That's not the case. That's not the case, Jason. Like if you leave 50 thou of material, if it cut a little heavy and
If it
left
cut
50,
five or 10 thou deep, it's not the end of the
yeah,
world. We still have material.
exactly.
Yeah.
Yeah. So the problem is we're making this toolpath really dense for no real gain. Because I don't, like you said, if it's plus minus 10 thou, I really don't care.
Yeah.
And that's exactly the way you need to look at it. I always like to set my total tolerance to about a quarter-ish of whatever my stock to leave is. That's a good, kind of metric. So if we're at 50 thou, we could just go up to like
12
10
30.
thou,
Yeah.
and
Yeah.
that'll be, 20% of it. Now, I'm just going to generate the toolpath real quick, and we can look at the result of that. Okay, so there's my toolpath here. So you can see right off the bat, we've already dropped almost a megabyte of data. And so, all of these little individual points, if we compare that to this one at the same point, you can see the points are a little further spaced away. We're not holding nearly as tight a tolerance, but there's still a lot of excessive points. So now that we've loosened that up, and the other thing that you may have noticed is that it did generate a decent bit faster because it's not trying to hold that super tight tolerance. Now we can come in here and we can say, I want to put on line arc filtering. And what that's doing is it's literally taking the toolpath that's generated. So it's not going to change the toolpath itself, but it's looking at maybe this row of lines, of points that it made, sorry, and going, hey, can I replace these with a single line? Or can I replace these with a single arc? And that's exactly what it does. So if I turn on line arc filtering, now I get to choose what planes do I get an arc in. Like, does my old machine only support G17XY arcs? The answer on your UMC, of course, is no. Your UMC could do G18 and G19, which are vertical arcs that happen in the XZ or the YZ plane.
Sure.
Now, to be fair, it's unlikely that we have any of those here, but maybe we do. I don't know. So, turn them all on. However, again, going back to that old Fadal that you got kicking around from 1982, that probably doesn't support these types of arcs. So it may error out if you try and run it. You'll have to figure that out for your machine. So the other thing that happened when I turned that on, though, is up at the top, I got this field that lights up now. And what this is doing is we're saying, okay, your toolpath is, basically plus minus 5 thou. We've got a total tolerance of 10 thou. Now, are you allowed to take these individual points of this toolpath, the individual vectors, and slide them around to fit an arc if it's better? And the answer is, yeah, man, I don't care. Let's slide that over. So basically, we're giving this thing permission to adjust the toolpath arc, and that's what this value up at the top means. So if I have 10 thou of total tolerance, so basically I'm going to be plus minus 5 thou of the original calculated line, how much am I allowed to slide it around to fit better arcs? Now, pragmatically, I find about 50-50 is kind of the limit of where things, stop happening. So I find just a 50-50 spread is good. Basically, you're allowed to slide things around 2.5 thou to fit a line or arc. So let's just see what happens here. All right, here it comes. So now notice that this one, and hopefully you can see that okay, but this one is 10 megabytes, and this one is a little over 1 megabyte.
Yep.
And you see you've got these nice big lines, and you've got actual arcs here in the corner as opposed to this one, with a bajillion little points. So every machine in the world pretty much is going to run this better, especially in 3-axis mode.
Yeah, and
It's going
I've
to be
I
happening.
actually ran into this when one of my first houses I bought was a no option machine, and it did not have HSM, and I
Oh,
was
yep.
doing some stuff, and it would, before I knew about this, it would just absolutely die in corners. I mean, it just, running at a high feed rate, you'd be an eighth of the feed rate around corners and get a lot of
Yep.
facets and things like that. And it really prevented the machine from choking on code when I, enabled that.
Yeah. And I run into the same thing. My garage machine's a 1998 Fanuc Robo Drill,
Yep.
and it's just straight up a processor limitation. It has high speed, but it still just has a, Fanuc being Fanuc. It's a 1998, which means that the processor was developed in like 1991 because it's solid and reliable, but it's not the fastest. And so I run into that same exact situation. All right, cool. So we got this roughed. One thing that I don't like about it though is you're going to notice if we look close at it here. So we got a good toolpath. I'm just going to delete the original one here. Um, but this top plane, this top face, of course, is being, let's do that top step, and then we're going to come up and we're going to do a spiral at the top. But this isn't going to hit anything at all. This is
Because most of
literally,
the thou we're leaving, but we're only 20 thou of stock up there.
yeah, you got it. Exactly. So this is where we'd use steep shallow to limit that. I'm just going to say start at Z0, right? That's the top of our stock here. So that'll slice that off and it won't be able to go up to there anymore. There we go. That's better. So now, and this is where stock models are absolutely useful. So if we create a stock model here, and I'm going to call this 100 after 0.5 roughing, and we're going to say that, you can either do it rectangular, or we could just say a model, since I already have this solid model here that I made with bounding box. We're going to go against that. And I want to see what remains after that toolpath. Now, one thing that will trip you up on stock models if you build a lot of them, and I use a ton of them, is your tolerances. They all add up, right? So this initial stock shape, how accurate does that cube need to be? I don't really care. 10,000 is fine. And the same thing for the result is it's going to follow the path within 5 thou, but it will do that with a 1 thou tolerance on our bull end mill. Well, that's also probably excessive when we're leaving 50 thou, right? So I'm just going to loosen that up a little bit. So give this a second to process. Okay, oops. Save that. Okay, so that's what our stock will look like, and that's probably not too bad. Now, what I would probably recommend for a part like this, because we're able to get probably a solid, I mean, if we look at this thing from the top, from basically here all the way around to here, we can get like, I don't know, 300 degrees of it finished in 3-axis mode. I would not get fancy at all in roughing this out with like a multi-axis roughing toolpath.
Okay.
What I would do is I would just create a plane that fit my view of, roughing this thing out. Something like that. Let's turn off the stock model for just a second and turn off translucency.
So like the edge of the tabs are perpendicular with your plane.
Yeah.
Yeah, like almost like you could machine the tabs in like a 2D contour if you need it all the way down to
Yeah,
the base.
exactly. Yep, you got it. Yeah, this view might be perfect right here, and we can do that. So let's just create a plane real quick. And we're going to do that where we line it up. Basically, I'm going to align it to one of these vertical edges of my tabs. I think they're vertical. Yeah, they look vertical. So hopefully that works out okay. So I'm just going to snap it, say, to this face, and then I'm going to move it down here, and we're going to rotate the Z 90 that way, and then something like that. And obviously you'll need to adjust this based on your specific machine, what the orientation is, whatever, get it aligned. But we're going to say this is the, we'll just say, ears, or whatever whatever you want to call them, clevis. This is a clevis area, we can call it that. And then what we're going to do is we're just going to come over here, and I'm going to move it. Now that I've got my orientation aligned this way, I'm going to just move that to match my G54 because I don't want any additional offset happening. We're going to be using that TCP function on your machine. But I just want to put this, the 0 position is still going to be back on my G54 0, right?
Right.
So you could just tell it, move this to my WCS origin. There we go. Now, if we look at, G54 versus this clevis, it's at the same exact place, which is, of course, the center of that stock solid.
So in practice, like in my 3+2 and my knowledge up to this point, I've created many different planes, and then I've always left the WCS as the original, where I indicated the part at, and then I would change my C plane and T plane,
Yep.
as I, moved around the parts.
Yeah.
Is this the correct way to do it, where you're just changing basically your plane orientation, but the the root
Yeah.
of the genome stays at the same place?
Yeah, absolutely. Because this is how Mastercam, and in any other cam system too, everybody will use a slightly different word, but it's all the same output. Basically, the WCS is just like the WCS on your control. As I like to explain it to people, that's where you tell it from where, right? Oh, I'm setting my 0 at the back left corner. I'm setting my 0 at the center top, or whatever, right? That's my 0. Now, the planes are really so we have from where, which is our WCS, and to where, or where are we going to? And so if you need to tilt this thing, and on your case, it's a BC machine. So if you're going to go, oh, I need to go B37 and C125, where is that B37 and C125 relative to? Well, it's relative to my G54. That's my WCS. And then your planes are just that. Sorry. Go ahead.
Some offset as well. Like, so I would have left my new genome like on the tab where you had originally.
Oh, okay. Yep.
And then it would have to calculate the shift and some form of offset in space as well, correct?
Right. Now, and this is where it's going to depend on your machine. Technically, if you have a properly defined post, there's really no reason to move your coordinate system to the origin.
Okay.
Because your machine should be taking care of that. And the post processor, if you're using a postability post, will, it'll be kicking out the right stuff anyway. If your machine cannot.
Or sound practice.
Yes, exactly. That's exactly what I was going to say. Yeah, you got it. So yeah, that's really what it's all about is, hey, if you end up using an old school Bostomatic machine that doesn't have anything to help you out, this is what you have to do.
Yep.
So it doesn't hurt on your Haas, but it will help on other machines if you're using them. So it's just kind of a sound practice. Exactly. So yeah, but basically now we've got this clevis thing, and now we can look at this as, we've got our stock here and our stock models, and this is where we could absolutely use a containment boundary. Because if we're going to use this same tool and we're going to attack it from this, we're going to attack it basically this way, we could say from a view, like, let me just create level, I don't know, 101, and we're going to say T1.5 end mill wireframe or something. And I'm just going to go draw this thing in, and I don't know the exact height, but I'm assuming 6 inches will be fine. And you could say something like, okay, I know I don't really want to cut into this material here too terribly much. So, the area that I would like to machine in is something like this. Probably need to make that a little bigger. You know. All right, so now we could create a dynamic toolpath, and we're going to basically use everything more or less the same, except we're just going to control it or contain it to this area here. And that's up in space, and that's okay. We don't, the height doesn't matter as long as it's correct in the plane that we're working in. Right? So we could even, if you want, I don't know, depending, I don't know if it's a time saving or not, but I'm just going to copy paste that toolpath. I'm going to change the plane that I'm working in. So we've got this clevis. And my toolpath control now, I'm going to clear that out and select this one. And then the other trick here is we're going to see what we get, but we'll probably need to tweak this steep shallow. Now, the last thing I need to do though is I need to enable stock. Because I want to tell it, I don't want it to think that this is a solid block of material. There's actual material there already. So let's tell it that there's one other operation we want to look at, and that's this stock model right here. All right, so start processing that, and this will take a second because that's a kind of complicated thing to ask it. There we go. All right, so obviously we'll have to, like we talked about, we're going to need some Z control here, right? And we might even need to tweak that that stock delete. And this is where, when you're doing multi-axis, you really absolutely 100% need to put in your work holding. Now, I didn't do that here, but you will absolutely, when you define your stock, put another level on there with your vise holding the part, right?
Yep.
Because you can't avoid it if you don't know it exists. But that's okay. Let's at least take a look at this. So first off, right off the hop, I don't need it. My boundary here is way too far out, right? Like that's just silly. I shouldn't have made it that far out. No big deal. Let's just do a dynamic. Let me adjust my control there, and we're just gonna slide that down maybe more like that. Something like that. Yeah, we'll just divide that, and divide that. Okay, cool. So that'll change that for the better. That'll be one problem solved. All right. And then of course, here we could just control it with the Z depth. But look at that toolpath. I mean, right off the bat, this is a beautiful toolpath that's contained very nicely only to remaining stock.
Yep.
So that's about as far as I'd go. So let's just come in here and we're going to say steep shallow. I don't care about the top. The top looks great to me. So I'm just going to come in and say that I don't want to go deeper than, say, this edge right there. And that's how you use stock models efficiently. Cool. And now we could create another stock model just to see what we got. And of course, any of these things we could verify. One thing that's really, really awesome is if you select a stock model and another toolpath, and you go into verify, it'll load that stock model for you.
Now, excuse my ignorance on stock
Yep.
models. Probably a very rudimentary question, but if I've created an operation and then I create a stock model that is the sum of that operation, if I go back and change that operation and the results are different, it automatically updates the results for that
Absolutely.
stock model, correct? I don't have to
Yep.
then make a new stock model, correct?
Nope. The whole stack will need regenerated.
Okay.
So yeah, we basically end up like this, and you'll have to tweak and change this to fit what your needs are and whatever, but at least this kind of gets you on the path, right?
Yeah.
So yeah,
Yeah.
this is how I would rough this out, because I don't think we need to be any more elaborate than this, especially in 6061.
Yep.
So at that point, I think you're probably good to start machining this and roughing it out. Now, obviously, we probably need to increase the stock model to get rid of like this bump right here or whatever, but you can do that. You get the idea.
Yep.
I don't want to drag it down too much. So let's talk about multi-axis then. So, again, and maybe this angle wasn't the best. Maybe you should have done, more of a, this angle or something like that, right? That's up to you. You could sort out whatever. Now you have an idea of how to do it. So let's talk multi-axis toolpaths. All right. So I'm going to turn off that wireframe. We're going to turn off that. And so basically, without going into a full 3-day training class, which is kind of my minimum length for a multi-axis toolpath, the things you need to know is that 90% of the time, Unified will get you there. And Unified is a collection of 9 different toolpaths from the company called ModuleWorks that Mastercam started using back in X5 for multi-axis toolpaths. Now, obviously, being that there are 9 completely more or less separate toolpaths, there's 9 different algorithms to learn. I'm just going to show you basically one of them right now that will get you there 70% of the time. And then, if you need some more help later, we can get together on it. So you've roughed this thing out. You're ready to do basically a semi-finish or even a finish pass on this outer cylinder. Obviously, the clevis faces are just more or less 2D, right? You can handle those. They're vertical.
Yep.
We can talk about how to do the round at the top here. We can deal with that in a moment. But for now, let's just focus on, I think, what's the hardest part, which is this floor. Because, that's the difficult one, right?
Yep.
So what I'd assume you would want to get is a C-axis style where we're just kind of spinning this around, and then if we need to tilt to avoid this, we do. And then we can go back to just kind of C-axising right here, if C-axis is a verb, right?
Yep.
So we're going to keep it kind of simple for this. Now, you might want to do it with a 1/2 inch and then come in with a 1/4 inch to finish this stuff. That's fine. You can probably figure that out. I know these are an 1/8 inch radius, so I don't know that we actually want to finish this entire thing with a 1/4 inch end mill. So let's start and see. I'm just going to do a 1/2 inch end mill, and we'll see how that works. Actually, a 1/4 inch probably wouldn't be too bad. You have a 15,000 RPM spindle, so yeah, we'll keep it simple.
I got all the time in the world, so.
Okay, so we'll just do it with a 1/4 inch to keep it simple.
Yep.
Obviously set up your feeds, your speeds. That's
Sure.
on you. I'm
Yep.
not helping you with that.
Yep, I got
anymore. So let's come over here. Now, one thing that is important when you're doing this stuff, especially in multi-axis, is that you define your tool holder correctly. Because obviously we need to tilt to avoid these clevis, walls.
Sure.
Well, we need to avoid the tool holder as well. So make sure that whatever you end up using, you've properly defined in here. I'm just going to choose this. We're going to say the tool's sticking out 1.25, and that's probably too big, but whatever. We'll just tool sticking out 2 inches. I don't care, whatever. But it is critically important that you define that for reality for you.
Yep.
Now, basically, what you have is a bunch of different things inside the unified toolpath. And again, I normally teach this. This is at minimum a solid day worth of training. So I'm just helping you out here. We're going to spend like a 1/2 hour or less on it. But you have a couple of different things here. And what you're doing is you're choosing the pattern. So for example, you might say that I would like the pattern, which is literally what do I want those blue lines that represent the toolpath. What do I want them to look at or look like when I'm done? So, you might want them to echo off of this square at the bottom, the bottom of your fillet, and echo across the whole thing. That would be a spline, and you'd say, oh, I want to use that, You might say that I want to machine something that blends from this one to this one. Well, that might be two curves and you set it to morph. What I would recommend doing at first for almost everything is just try automatic, which is the first one. Now, automatic mode takes whatever you give it for machining geometry, and it tries to create a pattern based on, whoops, I forgot the little flat. It tries to create a pattern based on the edges of that pattern, of the cut pattern or the cut geometry. So for example, it's going to take this top curve, it's going to take this square here, and then the bottom curve. And it's going to try and do if you're familiar with it, if you've used the toolpath, the equal scallop toolpath, it's essentially that.
Yep.
Which I love because it gives a consistent surface finish all the time.
So it's
Now,
basically looking at the base of the fillet as it affixes the floor of the cylinder, quote unquote,
yep,
as the boundary for machining.
exactly.
Okay.
Yeah. And then if we wanted to, we could, do a semi-finished pass. I want to leave 10 thou, and then I'll do another one that comes in at 0. You could also do depth cuts and stuff in here too, but that's okay.
Okay.
Yep. And so this, of course, your step over 50 thou for now. That's perfectly fine. Did you want to do it as a spiral, as a one way, as a zigzag? We're going to leave it as zigzag for right now. Just we're going to keep it very, very simple. We could change it if we don't like it or we want to see something different. So we come through cut pattern, and next is the tool axis control. Now this one is super important because this one is what controls how the tool tilts. Now you can lock this down all the way to 3-axis. I use this all the time on my robo drill.
Oh,
3-axis robo drill. Yeah, you could just say, oh, I want it to be 3-axis relative to the Z. There you go. It's now a 3-axis toolpath, or you could choose a different plane. In your case, you need it to be 5-axis because you want this thing to be in what's called normal to the surface. I basically want it to point at this green surface unless I need to tilt to avoid hitting the clevis.
Yep.
And so that is literally the default behavior, surface with tilt. And you'll see on my YouTube page, I do have another one talking about fixed angle to axis, which is right here. That's the one that I use probably 70% of the time. In this case, we want surface with tilt because we just want it to rotate the C-axis and be perfectly normal to here until you can't be because we need to tilt a little bit. So that's literally all we're going to do there. And so basically the cut pattern is going to be calculated, and then the tool axis control will be applied, and then collision control. For right now, I'm just going to turn that off because I just want to see what we get. So I'm going to green check out. All right, so this is showing us a toolpath where the tool is always perfectly normal, perfectly pointing out. Let me turn off the little dots. Always pointing to that cylinder floor. And you'll see it's like flat when we get over here. It's just staying, if we watch it play, it's just staying normal to the floor, just like you'd expect. And because it's a equal scallop, because we did the automatic toolpath, again, we didn't touch linking at all. The linking could use some adjustment. That's okay. But does the pattern look pretty good? I'd say, yeah. Like that looks like a great equal scallop style toolpath, right?
Yeah.
That definitely fits the bill. The only problem that we're going to have, of course, is right here is not the greatest.
Yeah, we got an issue there.
Yeah. But that's okay because what you need to do when you do a multi-axis toolpath is you need to tackle each step of it independently. So you need to look at the cut pattern and go, is this a pattern that I'm happy with? If I go out to the machine, am I going to be happy with these blue lines being the way they are? Yeah, I'd be happy with that. That's cool. Automatic saves the day yet again. Tool axis control. In general, am I happy with how this is moving? And the answer, of course, is yes. I don't like the fact that it's going to hit here, but that's okay. We'll deal with that in a minute. For the most part, everything looks pretty good, right?
And that's kind of where you talked about like this all being the trees being kind of chronological and
exactly
through them. Yeah.
Yep. And that's the thing that really, really trips people up. they will go through and they'll have a problem that might be caused by collision control because they told it to trim the tool, trim the toolpath if it hits. Well, if you do that, basically all of this in here is going to be cut out. Well, there's nothing you could do inside of your tool axis controller, your cut pattern, that is going to cause that to not be cut out, right?
Yeah,
You can't fix
you made the issue later.
exactly. But people will come in here and they're going to be like, no, 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 I need to extend this now, and I need to round corners, and I need to change my pattern, and I need to do all this stuff. And they turn on 100 little check boxes and they get way off in the weeds. So when I teach this thing, I literally make people a little card that says cut pattern with a checkbox, like tool axis control with a checkbox. Do not proceed to the next one until you're happy with what you have here.
Gotcha.
Because you will never solve a cut pattern problem. Like if you don't like this pattern, you will never solve that with collision control. It just cannot happen because cut pattern's already calculated. So yeah, collision control is really pretty snazzy. We're going to turn on, we have to tell it what parts of the tool you want to look at. And I want, in this case, I need to look at everything. And then you only really have a couple of strategies you could do, right? So if you're going to hit something, what do you want to do? Do you want to retract the tool? So if I'm going to hit, I want to pull straight back out. No, that doesn't make any sense. Do I want to tilt the tool? Yeah, absolutely. Okay, we can tilt the tool automatically. Great, that's exactly what I want to do. Or the other one is, of course, if you have a gouge, you could trim it out. In this case, when you do tilt tool, if you dig down through the trees, and yes, I understand that I'm skipping like 90% of the advanced controls here. That's okay. But one thing to look at is in collision control, there's this remaining collisions. And it says, okay, you've told me that I want to tilt to avoid collisions. But what happens if I tilt and I still have remaining collisions? Well, then the default behavior is to trim. So you kind of get a 2-for-1 deal here. You're telling it, I want to tilt the tool.
Just to
but
understand what trim colliding contours
Yep.
mean, it basically just means cut them off before the collision. Like if I'm proceeding to where it cannot not collide,
Correct.
It just is going to leave an unmachined area there. Correct.
Exactly.
Okay.
Yep, you got it. That's 100% it. Now, the other thing that happens is on the tool axis control or on the collision control page, you could have multiple tool axis control or multiple collision controls that happen. These are applied sequentially, just like everything else. So if you come in here and you say, the very first thing I want you to do if you get in trouble is trim the toolpath. And then the second thing I want you to do is tilt that tool automatically. Well, there's nothing for it to tilt the tool to avoid. It's already been trimmed. It's gone. So that trips people up as well. So if you're going to do it, if you're having a problem that comes in because of collision control, make sure that you're not giving it like, conflicting control.
But obviously, if you had 1 and 2 enabled,
Yep.
but it could solve the entire thing with 1, it would never ever get to the number 2 strategy, whether
Correct.
enabled
Yep.
or not. Okay.
Yeah, exactly. But the problem is if you tell it tool number 1, I want to retract the tool, then there's nothing left for it to tilt.
Yeah,
right? Because it's already,
yeah.
yeah, exactly. That's the thing that could trip you up. As I like to tell people, 90+% of the time you can get away with tilt tool automatic. Because that's really on a 5-axis machine, that's what I want. If you're gonna hit here, tilt the tool, figure out how to fit. But then the other thing we have to do here is along the top. Right now, it's already going to be doing that to the machining surfaces, to the green. But of course, that doesn't help us because these, the red is my problem, right? Or not red, what? The clevis ears. So I'm going to hit avoidance geometry, and I'm going to just, in this case, I'm just going to select the entire model because it's not going to hurt anything. It won't hurt that the floor surface is both an avoidance and a machining in this case, because I'm not going to be like telling it, oh, I want to leave stock on the floor here or anything like that. But if it did bother you, you could always, of course, just not select that.
Oh,
There
because
we go.
is avoiding the floor. I mean, correct. It's just machining, but it's not going through it.
Correct. Yep. Oh. Yeah, exactly. But one thing that can happen is if if you turn off machining geometries, then you could also tell it, oh, I want to leave an additional 20 thou along these surfaces or something. Now, the problem's going to be, in this case, we're relying on the radius of the tool to give us a beautiful fillet down here.
Mm-hmm.
So if you tell it to leave 20 thou, it's going to take this edge and slide that out to here. That's not at all what I mean, right? And you can't do that if you're also telling it to avoid the machining geometries. And again, this is not the best example of that. This would be where machining geometries would be good enough is if you were telling it, like, I'm machining a pocket and it's sort of deep, so I just want you to start tilting to avoid hitting the walls once you get to that point.
Yeah.
That's where that would come into play. So the only other thing to really pay attention to on here, there's some other settings and stuff. If you get into a weird situation, let me know, I'll help you out. But basically, the last question is, how much do you want to avoid things by? And the default is you stay 100 thou away from the holder, 25 thou away from the shank, and then 10 thou away from the shoulder. This is 100% up to you if it makes sense. Like, if you're going down into a
like
deep
your
little,
margin of
yeah,
safety, like how sure am I about the holder geometry or
exactly.
out? Yeah.
Yep. This is how much do you trust your calipers and your setup guy?
Understood.
Yeah. We're going to leave it like this. I mean, actually, I'm going to tighten it up just because I don't trust anything about this. We're going to say like 20 thou, 10 thou, and 5 thou, just because I want it to generate correct. I want it to generate a good toolpath. So we could get real close. The last thing to play with is linking, but let's just see what the toolpath looks like. I'm going to hit green check, generate a toolpath, and we're going to backplot it. All right, so let's just take a look here. So first thing to notice is that all of this stuff up here is completely unaffected. Anytime that we're away from that clevis area, it's gonna be perfectly fine because if we play this, nothing dangerous is happening here, right? So now, oops, I went a little faster there. So you'll see the same thing happening on the outside of the clevis. We're still normal to that surface. But as we come around the inside, you'll see that it's tilting to avoid that automatically. And let's turn off rapid moves. We don't need those now. So you see that is not staying normal to the floor anymore. It's tilting to avoid hitting that, which is exactly what you would want to see, right?
Yep.
I'm going to just jump ahead a little bit in here and we'll watch some of these paths in as we come in. Now this is where I think this tool holder is too big for the tool for fitting this in here. We'd obviously want like a slimline shrink fit, but I think we are getting all of it. It's just going to be a little jagged where it has to retract and pull out because the tool holder is hitting on the inside. Let me hit stop here and just jump around to a couple of points. See, this thing, it's saying, hey, there's no way that I could tilt that and still avoid the clevis by whatever I put in there, 25 thou. So I have to retract. And if we look at those retract lines, that's what we're seeing.
I gotcha.
So this is where, you really want to look into one of those, like a slimline shrink fit holder to do a part like this. I would absolutely be reaching for one of those things.
Or a tiny bit more stick out may solve it, correct? I mean, it's probably marginal in that instance.
Yeah, exactly. Let's see here. Yep. Yeah, you're 100% correct. But yeah, let's edit this holder. How big is that at the bottom? So if we went with something that was more like a 1/2 inch at the bottom, something like that. Oops. And then just delete that row, remove. And we'll make this one, like 0.75 or something. Like, there we go. And then stick that out. 0.25, I think we did, or 1.5 or something like that. So now, regen that toolpath. And we should see a little nicer motion through there as we can fit into that channel better. Yep. Yeah, there you go. You see how much nicer that toolpath
Yep.
looks?
Yep.
So it's not asking it at all to do those weird retracts. Even if it's in here, it can still fit nicely. So Shunk makes some great ones. There's, if you need a hand, let me know. I can help you find some slimline shrink fits, but that's exactly what those things are made for.
Now
Now the
that's assuming that we had machined the walls of that tab to
right.
actual, like we're 50 thou bigger than that in
Yes. Yeah,
actuality.
yeah. This would be after you finish the walls here. Absolutely. Yep.
Okay, yeah, understood. Okay.
Yeah. Sorry about that.
Now let me
Yep,
ask you. This is on my mind. It's I'm sure a stupid question, but
yep.
when using multi-axis and these unified toolpaths, in my little bit of experience with 3+2, of course, I always have to maintain my WCS and my planes. I have to honor them.
Mhm.
Does it matter at all, other than where the WCS is set, to have any type of plane or genome
Practically,
associated?
no. Nope, it really won't affect it. It's going to be everything's kind of relative to the WCS when you do a multi-axis.
Okay.
Yep. And that actually ties in. That's a great segue. So thank you, Jason. Because
So
that brings me to the last thing I wanted to chat with you here about, which is the linking. Obviously, this linking is not at all efficient and not good, really. Um, let's be honest, it's just straight not good. So as you see, this thing is going in the z-axis 6 inches up, right? So this is our z0 up here, and it's going to 6 in the z-axis plane. Obviously, that's not desirable, right?
yeah.
So this is the last thing to fix. And again, do it sequentially. Do not bother with your linking moves until you've got everything else sorted out. So this page looks really intimidating. It's not that scary once you understand what's happening. So just as a quick rundown of everything, the area we really want to fix is right here, but I'm going to start at the top. So the entry exit is literally what do you want to do for your very first entry and your very last exit of the toolpath? Now, on my very first one, I'd like to use a lead in and use a lead out. So on our first one, we're using a lead in, we're using a lead out. So it ramps in nice and smooth. It doesn't just plunge right onto it, right? Now, the next thing is what happens if you have a small link versus a big link? And what that means is you'll notice over here when it's zigzagging, because that's the pattern that I have it to, it's doing little loops. But at some point, it gets to a big gap and it does a jump where it retracts back to the clearance plane. And that's exactly what you're seeing here. So you have a small gap. And what is a small gap? In this right now, this means anything smaller than 100% of the tool diameter, which is the default behavior. But you could say, oh, I want anything less than a ½ inch to be a small gap, or whatever number you want to type in. And what that means is that in this case, I want to link this way. Now, there's some helpful little graphics right along the side here that'll walk you through what everything's doing. The default's generally good for a small link, which is blend spline. So it's basically going to be just like as if you created a blended spline from one side to the other. And you see that right there, where it's just kind of sweeping from one to the other. Looks great, right?
Yep.
And then if it's too big, we want to retract to the clearance area, which, yeah, that's probably fair. Now, the problem is our clearance area looks like crap, but that's okay. We can fix that. So with your clearance area, you have some different types of shapes you can have. We can do a plane, a cylinder, or a sphere. Obviously, in this case, we are machining the entire way around this thing. A plane does not really make sense. I don't always want to retract in the Z or in the X. In this case, I think a cylinder makes a lot more sense. Now, when you do a cylinder, though, you have to define it. Where is that cylinder lined up to? Well, this thing, I'd pretend that I would want this thing to have a cylinder basically starting at the center of this hole and working outwards, right?
Yep.
So we're going to say z-axis. Now, through is where is the center of this cylinder, and I'm going to just choose this center point here. And then what's the radius? Well, the radius is, I'm just going to measure from the center of this cylinder out to, say, here. And it looks like in 2D, that's about 3 inches, which makes sense. So we're going to say that the radius is like 5 inches. All right, now I'm going to hit apply here, and apply will preview the toolpath, so we'll be able to see it. And there we go. Now your linking moves are happening in a much more logical fashion. And the other thing we could do too is we could say anytime you have to pick up to go to a clearance area, we do want to use a lead in, lead out. But don't do it for a blend. Don't do it for something small. Anything you're keeping down on the surface, we don't want to lead in, lead out. But anytime you have to pick up, then give yourself a nice little lead in, lead out like that. And that looks a lot better.
Where are the lead in, lead out parameters defined when you're saying use lead in, lead out? Is there a definition for that?
Absolutely. Right here on the default lead in, lead out page under linking.
Oh, I'm sorry. I didn't have it expanded. Okay.
Yeah, no problem. Yep. And now normally you could get away with just leaving everything in automatic.
Mm-hmm.
And then maybe controlling the size. So by default, this thing's going to try and put in a 120 arc radius, and it's going to fit it as long as it could fit anywhere down to a 40 thou. It'll still put it in arc. If it's less than that, it's just going to drop it straight in, no arc at all.
Yep.
But you could adjust this, right? Like depending on the size of your part, the size of your tool, you might be like, no, the biggest arc I want is like 50 thou. And the smallest arc can be 10 thou. Or whatever fits your lifestyle, Going to be a little part specific because if you're working on a bunch of tiny tools, 120 thou arc is really big. If you're working with 3/4 inch end mills, then 120 arc might not be enough, But yeah, so now you see that linking move is happening, and it's avoiding everything real nicely, and it's coming out to a cylinder. So one other thing I'm just going to leave, I think this will probably solve most of your problems, or at least get you down the path to start. And I know that this is already going to be like an 1.5 hour video, so nobody's going to watch it. The other thing I want to leave you with is the feed rate control page. Because what you probably don't want to do, now on a modern machine, it's not nearly as scary as it used to be. But rapid modes in multi-axis used to be a real big no-no because the machines really had no clue how to sync things up, and they would sometimes gouge through the parts or whatever. So if you want to be 100% safe, I recommend on the feed rate control page setting replace rapid with feed rate. And you can come in here and you can be like, oh, instead of doing any rapid moves at all, I want you to just move at 500 inches a minute, feet, in a G1 mode.
Sure.
And all that's going to do is just come down and replace all of those rapid modes with a feed move. And, all that does is ensure that your machine will stay synchronized for everything. So, yeah. And I mean, you could play around with this, the automatic mode and everything, do the top of your clevis with automatic mode. That works great. You could also do 2 chains and do a morph from one side to the other just to do the top. You could use, automatic mode here. Like, let's say that we do a single clevis using everything. I'm keeping everything exactly the same, but let's just do automatic mode. And I'm going to say, just do that one clevis. Now, your tool axis control in this case, we don't want that to be normal to the surface. We don't want it pointing at everything. Like I don't want the tool to be perpendicular to this face. So this might be a case where we do go fixed angle to axis, and we say, I want to be fixed to this line, and maybe choose that line. So basically we're saying, I want this to be a 3-axis toolpath, but I want to tilt away if we're going to hit anything. So I'm just going to hit green check. All of the settings are the same as they were before, other than that one. And let's just see what we get. So we probably don't want to start at the bottom. Oops. Oh, we also don't want to, we don't want to include this circle. Whoops. But, the toolpath itself is fairly solid. So let's come in here and I'm just going to uncheck that circle from my cut parameters. There we go. And the other thing I'm going to do is I'm going to adjust my linking now because I want to stay down as long as the distance is less than that diameter. So I just right click and hit diameter of an arc. I just previewed that. Let's see what that looks like. All right, not bad. What I'm going to do though is I'm going to show you one of the advanced options in here where we come down, I'm in the cut pattern because I don't want it to include this shape. I don't want that to be part of my features when I'm machining the side. So if we come down here into Machining Geometry's Advanced Features, I can tell it to fill the hole. So what that's going to do in the background is it's going to take this hole and it's going to pretend that it's not there.
Oh, wow.
Isn't that neat?
Yeah, I was getting ready. You took the words out of my mouth. I didn't know if I had to create a surface and fill that hole or fill it as a solid. Yeah.
And you absolutely could have, and that would have been perfectly fine. But, you know, like overall, that's really not that bad.
Is there a way to do top-down strategy versus bottom-up?
Absolutely. Yeah, because what's happening is this is looking at it right now, and it's starting on what it considers the outside of the pattern.
Yep.
So literally the right on the cut pattern page. So this is, again, I know you understand this, but I'm just repeating it so you get the verbiage in your head, right? Or the thought process. You're telling me that the cut pattern, you want to reverse that. Okay, cool. So we have to look in the cut pattern area. And that's a common thing that you might want to do. So if we look right on the main cut pattern page and you start reading about things, it's like, oh, there's flip step over. Okay. No, I don't want autosave. There we go. That's more what you want.
Yeah, that's awesome.
And you can play around, you can do guide modes and really force the pattern to do what you want. I kind of get into that a little bit on one of my other videos, but that's a whole nother, that'd be another
I
hour.
didn't be able to get a finished part in this instance, which I mean, you have definitely. I mean, I'm grinning ear to ear over here with what you showed me. So
Cool, man. Well, I'm going to stop the recording here because I think that's a great place to leave it. And nobody on YouTube still watching, so do stop recording. Okay.